Galvorn carbon tube wire, a wire without metal. The world of materials science is ever evolving, pushing the boundaries of what we once thought was possible. Imagine a wire, powerful, efficient, and reliable, yet it contains no metal at all. This is the vision behind the concept of the Galvorn carbon tube, an innovation that challenges our fundamental understanding of electrical conduction by leveraging the remarkable properties of carbon-based materials. For centuries, metals have dominated the realm of conduction, serving as indispensable conduits for electricity in everything from household wiring to vast power grids. However, metals come with drawbacks: weight, susceptibility to corrosion, and sometimes, even limited flexibility. The idea behind the Galvorn carbon tube is to sidestep these issues by exploiting the conductive capabilities of carbon, a material every bit as abundant as it is versatile. Essentially, Galvorn carbon tube is a leap toward redefining conductivity with a material that is both lightweight and robust. Modern studies in nanotechnology have revealed that when carbon atoms arrange themselves in tubular structures, commonly known as carbon nanotubes, the result is a material that can exhibit excellent electrical conductivity, mechanical strength, and thermal stability. These nanotubes can form networks that mimic the pathways of electrons in conventional metal wires. The Galvorn carbon tube draws on these principles, proposing a system where interlocking carbon layers or strands create a continuous, conductive pathway without any trace of metallic additives. The notion of a wire without metal is not merely a semantic twist, it represents a fundamental transformation. In an environment where corrosion, electromagnetic interference, and the physical weight of metals can significantly impede performance, a carbon tube offers a cleaner alternative. The carbon framework can potentially be engineered to optimize electron flow, ensuring that the wire is not just a passive channel but an active participant in enhancing overall circuit efficiency. What makes the Galvorn carbon tube particularly intriguing is its potential to revolutionize diverse fields. Lightweight and flexible electronics, in the realm of wearable and foldable devices, reducing weight is crucial. A wire composed entirely of carbon tube could significantly enhance the portability and resilience of such devices. Corrosion resistance: metals deteriorate over time, especially in harsh environments. Carbon-based wires could dramatically extend the lifespan of equipment used in critical applications, from aerospace to deep-sea exploration. Energy efficiency: carbon nanomaterials have shown promise in reducing energy losses typically encountered in metal conductors. In power distribution systems, this could lead to more efficient transmission and less energy wastage. Biomedical advancements: the biocompatibility of carbon paves the way for its use in medical devices and implantable electronics. A non-metallic conductor minimizes risks of allergic reactions and other complications associated with metal implants. Galvorn carbon tube appears to be on a track to achieve price competitiveness compared to traditional metal conductors like copper. Recent information shows that Dexmat has accomplished significant cost reductions. Reports indicate that through a 3000x scale-up in production, costs have been reduced by up to 99.6%, reaching a critical inflection point in which Galvorn is not only technically superior but also cost-competitive in several applications. However, it's important to note that the cost-effectiveness of Galvorn carbon tube must be evaluated based on the specific application. Although Galvorn is much lighter and stronger than copper, being about 80% less dense yet 50 times stronger, its volumetric properties mean that in scenarios where the wiring is designed for high conductivity per unit volume, more material might be needed to match copper's performance. In these cases, the economic advantage might depend on whether the savings obtained by using less weight or achieving longer durability offset the volume differences. Ultimately, while initial indications are positive, the true cost advantage of Galvorn carbon tube will also depend on factors such as production scalability, integration into existing systems, and the target market's requirements, especially in sectors like aerospace, automotive, and wearable electronics that demand both performance and lightweight materials. As the technology continues to mature, the market will likely see more detailed cost comparisons and assessments that could solidify its position as a cheaper alternative in the right scenarios. The creation of the Galvorn carbon tube symbolizes a broader trend in technology, one that values sustainability, efficiency, and a harmonious blend of nature and human ingenuity. While metals will continue to play a role in our technological infrastructure, the exploration of carbon-based alternatives opens the door to a future where materials are chosen not just for their historical utility but for their alignment with future needs and environmental considerations. This paradigm shift is as much a philosophical breakthrough as it is scientific. It invites us to reconsider the elements and compounds we have so long taken for granted and challenges us to think differently about the building blocks of modern civilization.